Okay, here we are. Hi, everyone. Great to have you online today. We are really excited for this webinar, which is the culmination of an earlier year of work around developing a prototype for a blockchain database for sustainable biofuels. I am Arianna from the RSB, and I'm joined today by Patrick Lynch from Bioledger. And the webinar today will be about 1 hour long, and it will be recorded. So for those of you who are joining late or couldn't make it, or those of you who want to listen to it again, we're going to share a recording next week. And we'll go through the following points of the agenda. So I'm going to bring you through an overview of the projects and the project partners. And then I'll ask Patrick to bring you through the results. So he's going to talk about how blockchain works, how it can address the risk of fraud. He's going to share the results of an industry-wide stakeholder survey that we conducted during the project, show you a bit of how the blockchain database works, so a demo of the database. And then at the end, we're going to share some learnings, and we will provide some time for a question and answers. So with regards to the questions, you will be able to ask questions throughout the webinar using the chat box. There is a Q&A box actually that you can use for questions, and then there's a chat box that you can use for any other comments, but we suggest to use the Q&A box for the questions. So I'm going to kick off by providing you an overview of the projects and the partners. So first of all, let me give you an overview of a quick overview of the RSB. RSB is the Roundtable on Sustainable Biomaterials. Most of you, if not all of you, I'm sure, know us very well. We are a global multi-stakeholder organization that offer advisory, membership, and certification services to the bioeconomy sector and advanced fuel, advanced economy sector on a global scale. We focus on bioenergy, fuels, as well as materials and textiles. The sustainability certification that is offered by the RSB is recognized by a number of regulators, including EU RED, and soon we are receiving our ICAO recognition for our CORSIA standard. And me, Arianna, I am based between Europe and South Africa, currently in Cape Town in South Africa, and I lead RSB's aviation portfolio as well as strategic projects like this one. And I'll ask Patrick to please introduce himself and Bioledger.
Thanks, Arianna. Hi, everyone. Thanks for joining. My name is Patrick Lynch. I'm the founder of Bioledger. I've worked in the biofuel industry for over 15 years, and I set up Bioledger at the end of 2019. And that was in direct response to a problem that the industry found ourselves in throughout 2019. There was a demand from the industry to develop solutions that strengthened the sustainability verification of the biofuel supply chain, and that solution needed to be an independent solution. So I spun out from my previous job as head of sustainability at the UK's largest supplier of road fuel and Europe's largest producer of waste-based biodiesel. And worked with the stakeholder group to build a solution, and that solution is Bioledger. And working with the RSB and the IC Innovations Fund has allowed this stakeholder group to really elaborate on the problem and the solution. And we're looking forward to presenting you with those, with the outcome of the project today. Thank you.
Great, thank you, Patrick. So also as part of the project, we need to thank also our pilot partners. So companies playing a role in the UCO biodiesel supply chains and that participated in the project and tested the pilot. These were Greenergy and Benson's products from the UK. We also had Rexon Energy from Singapore and Valley Proteins from the USA. And then obviously last but not least, the funder, the IC Innovation Fund, which is supported by the Swiss State Secretariat of Economic Affairs. ICL Innovation Fund is a fund managed by ICL, and ICL is an umbrella organization of credible sustainability standards. They are the ones that make sure that sustainability standards follow strict procedures to make sure that we involve stakeholders appropriately, and we also manage our standard development and our indicators in a robust way. The Innovations Fund was created in order to drive innovation in the sector of sustainability and also to promote the uptake of sustainability in the sector and to promote also collaboration among the standards. So thank you again to the funder for making this project possible. So I'm going to bring you through a few slides just to give you a very brief introduction on the RSB. RSB, I mentioned earlier, is a certification, but we are not just a certification. We are a mission-driven organization that supports the bioeconomy sector. Everything we do is based on our 12 principles and criteria, which is robust and comprehensive management way to produce biomass, advanced products, advanced fuel and energy in a sustainable way. Something very important to notice is RSB's governance structure, and this is because we try to convey our learnings and expertise into this project, and this is basically to ensure that our work and our standard is built on based on stakeholders' expertise and also on stakeholder consensus. Our governance, well, our membership includes both industry, but also we have a number of social and environmental NGOs that participate to ensure that the standard is not only practical for industry, but is also credible. And here is a snapshot of who is currently in the RSB membership community. Bioledger is one of our members, and you can see here there's quite a number of industry leaders in both also in the ground transport and biofuel, biodiesel sector. So with regards to the project, so the overall objective of this project was to develop and test a prototype of a blockchain-based database to enable traceability of sustainably certified used cooking oil and biodiesel sold in the European Union. So really, just to summarize, we wanted to test the feasibility of blockchain to serve the needs of the biodiesel sector and biofuel sector overall, to ensure that the supply chain is more credible, is strengthened, and that we reduce the risk of fraud, which we understand is one of the key issues around the industry. The time frame of the project is, so the project started in January, running through September, and we launched the project in February. Conducted an industry-wide stakeholder survey in March. We developed, well, Patrick is going to share more information on the results of this survey. During April and May, we developed a prototype of the blockchain-based database and also presented the draft prototype and the draft concept to the biofuel database stakeholder group, which is a stakeholder group, an industry stakeholder group that also provided insights to the European Commission for the development of a union database, which is one of the European Commission's focus for the next years. We ran pilots together with the pilot partners in May and June, reviewed the prototype, and also conducted, we asked two auditing firms, so SCS and Control Union, which are also accredited to do RSB audits, to do an independent system audits on the database. And now here we are in November, sharing the results of the study. So I'll ask now Patrick to share his screen, and he will tell you more about the rest of the agenda and going through some of the project results. And Patrick, you're on mute.
I had to unmute, yeah. Thanks, Arianna. And again, good morning, good afternoon, everyone. So yeah, the project has been a really comprehensive project, and it had almost perfect timing in that the biofuels industry was faced with maybe not an existential problem, but a problem that really highlighted that the systems for verification of sustainability need to stay up to date, and that's up to date with the most prevalent risks associated with the supply chain, and also up to date with the best available technologies. And this project leads on from an ICL Innovations project, also run with in partnership with RSB in 2018, that looked at the potential for blockchain to offer extra security for the biofuel sustainability supply chain. And if you look at the biofuels use case, it's easy to say that risk in biofuels is an extremely high risk supply chain. The very nature of the market is totally dependent on the indistinguishable physical components and fuel products being able to guarantee the traceability to the point of origin and the environmental sustainability of their production. And they need to make those guarantees to not only their next customer in the commercial supply chain, but also to governments who create the policies that define the markets and place a value on those sustainability credentials. And the governments are also answerable to consumers and taxpayers. So if you consider the potential environmental risk associated with the production of agricultural commodities in general and biofuels as a sector of agriculture, then and you balance the bold claims that biofuels make, that biofuels are a low carbon alternative to petrol and diesel, that their production doesn't cause deforestation or loss of highly biodiverse lands, and that their overall life cycle carbon emissions are better than petrol and diesel and make a significant contribution to the fight against climate change. And compare that with the potential risk that identical molecule may have a different sustainability outcome. And when you consider those other alternatives in the waste biodiesel supply chain, a molecule of biodiesel from used cooking oil, which has all the sustainability credentials and therefore the sustainability premiums associated with its better environmental characteristics, like removing waste from our inner cities and having no land use impact, and compare that to the environmental impact of maybe the worst vegetable oil that you could swap that for, and the potential negative outcome of, say, deforested palm oil being then claimed as waste-based biofuel in Europe is a huge spread of risk when you consider the environmental risk, but not only the environmental risk, but the trading risk. So the premiums associated with the sustainability evidence can equate to more than 50% of the value of that commodity. So the European governments have created markets that are highly in demand for waste-based biofuels, and the paper-based evidence that justify those environmental credentials can be worth up to more than $500 per ton. And on the basis of those premiums, the biofuel industry and the oil industry are making bets essentially in the order of hundreds of millions, if not billions of euros every month. And the policymakers also are justifying removing that taxpayer premium and awarding it to the biofuels companies because they believe completely that this is the right thing to do to reduce the carbon emission of transport and make contributions toward avoiding the worst effects of climate change. So it's an extremely high risk supply chain, environmentally, trading, investment, and policy wise. And the only way to manage that high risk and justify those investments are by developing robust systems for traceability. We need to understand the risks and address them appropriately. And the industry has done that for the last 10 years. We've traveled the world to identify the most efficient biofuels for reducing carbon emissions from transport. But we've also had to put in a lot of groundwork to prove the sustainability of the production of those biofuels. And when I started work for Greenergy 10 years ago, the first supply chain that we had to focus on was sugarcane ethanol in Brazil. And working with RSB and the other voluntary schemes and the rest of the industry, we were able to develop appropriate standards that identified and addressed the risk using the best available technology. We used satellite land use evidence to prove there's no land use change or loss of highly biodiverse lands, and we used social sustainability audits to prove that the workers were that the social conditions were met the standards of the industry and the policymakers. Now, when the market moved to used cooking oil and the policymakers favored waste-based biofuels, we also had to move into a new supply chain. And I would say, because we had developed systems of certification that allowed us to put faith in the certification of suppliers, rather than having to do the legwork of vetting each and every new potential supplier, the industry developed an element of hubris and maybe too much trust in the systems that had been elaborated over the previous 10 years. And in 2019, that resulted in a systems failure where the Dutch ILT agency reported to the Dutch Parliament that one producer of fraudulent biofuel in the Netherlands had claimed up to 30% of the total renewable fuel market in the Netherlands using fraudulent documentation to prove that sustainability evidence. So clearly the industry needed to address that problem, and we did that by developing Bioledger and by forensic investigation of that problem, along with the voluntary schemes. And thankfully, the voluntary schemes like RSB have those procedures in place to be able to perform stakeholder reviews, assess the new risks, and by stakeholder consultation, come up with the most appropriate strategies to deal with those risks. So in those forums within the industry associations, in particular EWABA, the European Waste and Advanced Biofuels Association, we did the forensic analysis of those risks. We talked about it with auditors, we talked about it with competitors, we talked about it in the pub, and tried to understand all of the allegations that were being made about each other, that were being made about the supply chain and auditors, and tried to identify the weak points. And when we list those identified weaknesses, we can categorize them into two sections. One, the whole system is dependent on the trust that buyers place on the certified status of their sellers. So if a company holds a certificate according to a voluntary scheme, the buyer can trust that the consignments they've received from that seller meet the requirements for sustainability and traceability. And associated with those certificates are the audits. The auditors issue the certificates on the basis that they've reviewed that supplier. They've taken a representative sample of the consignments that have passed through that supplier supply chain, and they make a statement along with the voluntary schemes that on this limited assurance opinion, we verify that this seller is allowed to make as many claims as they like on the quantity of sustainable biofuels that they sell for the next 11 months until the auditor reviews them again. The other kind of pillar of the trust in the supply chain are the claims that are issued for each consignment. And whether you're a used cooking oil collector collecting oil from a restaurant, or you're a biofuel producer that sells sustainable biofuel consignments to oil majors, or you're an oil major who's reporting to the government, the evidence for that of the sustainability for each consignment is evidenced by one document, and those can be known as the self-declaration from the restaurant or a proof of sustainability. And essentially, that's the second weakness that we identified, that if people can make a claim on a piece of paper, or an administrator can make a claim on an Excel template or a PDF document, and they can issue those claims until they come up to their next annual audit, then those claims are vulnerable to forgery, to multiple use within the supply chain. So someone can use that piece of evidence more than once against different consignments. And also those claims can be hidden during an audit. The other element is that the auditors are constrained in their visibility. So when an auditor performs an audit against one of the voluntary schemes, the legal constraints do not allow the auditor to look outside that auditee. And that again means that potentially non-compliant fraudulent consignments can be hidden from the auditor. And so when we addressed both of these risks, lack of visibility during audits and lack of trust in the paper-based claims, we came to the conclusion that a database could resolve some of these issues. If all of the claims are made within one central database, then the regulators can always have visibility and verify those claims. Auditors can perform audits more efficiently and have better access to all of the claims, and they can corroborate those claims with the person who wrote the claim. And the digital consignments can be trusted more. So the industry identified a technical specification and a governance specification for a database that they could support. The European Commission also wrote into the Renewable Energy Directive, Article 28.2, that the European Renewable Energy Directive has to have a single European database for biofuel traceability. And understanding the problem and understanding the potential solution, and knowing that the European Commission and the regulators of each of the member state markets would impose a database eventually, I took it upon myself to set up Bioledger, because I knew that it would become my job anyway to push adoption of this database through the global supply chain that I was already working with. At that point, I was head of sustainability, responsible for all biofuel supplies into Greenergy, but I was also a trader. And I talked to the used cooking oil collectors, and from understanding that part of the supply chain, these are people who have been collecting used cooking oil for generations, small to medium businesses based in industrial estates, outside cities, inside cities. They drive around in the middle of the night and in small vehicles often, and they already find the burden of compliance difficult, and they lack a standardized reporting template that they can trust for their own compliance. Because, and with this fraud case, they also were very keen to protect their legitimate claims, and the same applies for all of the IWABA members and many of the other stakeholders that were involved in this project. When a company is doing something right, they want to protect the value of their supply chain from the criminals who would try to make up those fraudulent claims within the audits or within the supply chain. So I knew we were in a position with RSB's very open stakeholder engagement structure, and with my fairly central role in the global used cooking oil to biodiesel market, to be able to act as a hub for these very international stakeholders, and try to design a database that suited both the regulators and improved transparency and trust in the claims, but also protected the users and the consumers of sustainable waste-based biodiesel. And not only that, but any solution needs to be fit for purpose. If this is a very burdensome user interface or administrative process, then you're not going to encourage adoption amongst the white van drivers around the world. So it was important to me as a used cooking oil buyer that whatever database was eventually mandated by the regulators in the industry had to be suitable for use in China, in the US, and in small to medium businesses. So when we as an industry and as a stakeholder group started talking about the potential databases that we could build, every developer of or provider of database technologies said that blockchain was a perfect use case for this supply chain. When you outline the problem, we have a very high number of companies that do not trust each other. They're performing fairly simple transactions between each other. The problem is the traceability of those claims and trying to mitigate the risk of fraudulent claims within the system, and also to provide extra transparency to regulators. They all said that blockchain is a perfect technology for us to pursue. So we set up Bioledger, and with the RSB and the IC Innovations Fund, we started to work through the concept about how blockchain could potentially provide a better solution than a traditional database. And in this project, I'll outline how we did that. So the concept of blockchain, there are three particular characteristics about a blockchain database that make it different from a standard database. And those three characteristics also make it particularly useful to resolve our problem in the biofuels use case. Those characteristics are the transactions that get recorded in a blockchain database have to comply with what's called the consensus logic. And the consensus logic is code written by the blockchain developer. But what that code does is create a set of rules that every new transaction has to comply with in order for that transaction to be recorded in the database. It's like a due diligence tool that sits in front of your database to say, is this a valid database entry? And that's good for our use case because we have a very clear set of compliance rules defined in the Renewable Energy Directive and in the system documents of the voluntary schemes like RSB. So the second part is that blockchain facilitates truth, in essence. In a traditional database, any record can be edited or changed or deleted. And maybe or maybe not, there may be a log of who performed those transactions and why. In blockchain or in a distributed ledger database, there are trusted peers who host a copy of the blockchain ledger, and those copies are updated simultaneously and identically. So if any one entity makes a change, if any one entity makes a change to any transaction in the database, first of all, it has to comply with the consensus logic to be written into the database. But also because multiple trusted peers host a copy of the distributed ledger, everyone in the network can see when a transaction happens. And if there's something wrong with one of those transactions, then it can be investigated potentially by the authorities or those trusted peers. It also means that there's only one copy of the truth. So if an auditor or regulator needs to understand the historic transactions that have happened in the whole market, they can see that in any copy of the distributed ledger. And So I'll show you, just by talking through this diagram, I can show you how a blockchain transaction would happen in a biofuels use case. So when a company, say company A sells to company B, they want to perform a transaction and they want to record that transaction in the blockchain database. That transaction is represented by a data set, and that might be the seller's name, the quantity, the type of product, and the buyer's name. That data set then gets presented to the network of peers who host the blockchain network. Those peers automatically, the consensus logic of the blockchain code performs its checks on that proposed transaction, and if that transaction meets the consensus logic, then the network permits that transaction to be recorded into the ledger, and it creates a new block, and the block is essentially the package of data that summarize the transaction. So who the seller was, what the product was, the quantity, and who the buyer was. And that block gets written into the ledger so that everyone can see that that transaction has happened. So anyone will be able to see that the title of this consignment changed from seller A to buyer B. And those blocks are created for every transaction associated with that consignment. So when this consignment is later sold to company C, company B will again propose a transaction to the database. The database will assess it against the consensus logic, and a new block will be generated and added to the blockchain. So not only is that useful in being in embedding the compliance logic into the transactions, but at any point a regulator or an auditor can pick any consignment and read the chronological life cycle of all transactions associated with that consignment, and everyone in the network can see who currently owns that consignment. So in taking these attributes and trying to apply them to the biofuels use case, we have to make them specific to our problems, and we can do that because we have buyers and we have sellers. We have more or less a consensus logic, which is the requirements of the RED and the normal business logic of the biofuel users. In theory, we can have trusted peers, and they might be the European Commission or the RSB, and yeah, every entity in the supply chain needs to see all of their transactions and the available consignments that they have, and they need to be able to present that data to an auditor or a regulator if there's a surveillance audit. So we set about working with the industry to help define how we can design this system to make it perform the consensus logic of the market and the business logic of the users. And of course, if you put all of this supply chain information and all this transactional data into one central database, the biggest concern of the industry users is the confidentiality and the security of their information. So we set about trying to define the security specifications for a database and the roles of each of the stakeholders within the database. So who should have access to see different types of information. In this example, buyer B only needs to know that their consignment that they've bought is compliant. They don't need to see all of the previous transactions that were performed by company A. Company A doesn't want to disclose their entire supply chain to company B. They just want to prove that it's compliant. So we set about going through a stakeholder process. We had an extremely good response, I would say, to our project. We had 103 respondents, and they represented biofuel companies, regulators, auditors, and industry associations from all around the world, every part of the supply chain. And they helped us define the scope of the database and how the database should work. by indicating where the risk lay in the supply chain, they gave us the scope. So they said that the risk is highest at the beginning of the supply chain, at the first collection and trading and processing of the feedstocks. So that told us that whatever database that we create and whatever user interfaces we develop need to be appropriate for the first collectors of the used cooking oil in this case. And that means that we have to develop an app, a mobile interface for drivers of used cooking oil collection companies to record this evidence, and to generate the consignments in the database. This diagram at the bottom is not very clear. It's quite small. You'll be able to see it in the slides later. But essentially, the stakeholders identified the scope of the data that they would like to hold within the database, and primarily those are only the mandatory reporting sustainability characteristics for the voluntary schemes. So they needed to identify the seller's name, the buyer's name, the certificate number of the seller, the feedstock type, the greenhouse gas savings, the previous land use change of the biofuel consignment, in order to prove that they comply with the Renewable Energy Directive. Other data points that were potentially useful, but that the stakeholders said they weren't too keen on including in this central database, were things like the company names, the operator names, the loading address, the delivery address, the vessel name, and stakeholders were against inclusion of things like the commercial terms of the transaction, like price and the quality. So we identified the data points that would need to be carried in the database. And again, the highest priority for the stakeholders was to make sure that their commercial information could not be disclosed to anyone with a commercial interest, and that it would only be disclosed to those entities that needed to see it, so their auditor and potentially the member state regulators. The other thing that we identified was that users wanted us to be friendly, to design a user-friendly interface that would encourage adoption, because at the moment this is a voluntary initiative. It hasn't been, a database hasn't been mandated by the European Commission or any of the market regulators. So we needed to make this user-friendly and attractive to use. And the most interesting part of this project, I think, is the discussion about governance. And during the stakeholder interviews and work with the IWABA group, and actually work with the European Commission, we identified that the biofuel sector is lucky in this case, in that we've got very clearly defined user roles and responsibilities. The user is responsible for performing transactions and making sure they're compliant. Their certification body is responsible for checking compliance of those transactions against the rules of the voluntary scheme. And the member states are responsible for verifying compliance for transactions into specific markets. And then the European Commission and other kind of federal level regulators are responsible for making sure that the whole system works in a robust way, and that we can meet the targets of the Renewable Energy Directive. So that helped us design the architecture of the prototype. So I guess we've got a lot to cover, but we're short of time. So again, luckily, and I suppose it's just in response to the fraud investigation in the biodiesel sector in 2019 in the based in the Netherlands, but across Europe, the industry and the Dutch regulators and the European Commission sought to address these same problems that we have with lack of transparency in the supply chain, lack of trust in the claims. and the risk of fraud. And so this pilot project ran in parallel to those three pieces of work by EWABA, MVO, EBB, and the Dutch Platform for Sustainable Biofuels, and Guidehouse, the consultant working on behalf of the European Commission. And Bioledger and RSB and all the pilot project partners who were involved in each one of these stakeholder discussions. And as an industry group, and as these 3 or 4 projects, we helped identify those roles and responsibilities in the supply chain, the technical specifications for a database, the governance specifications for a database. And so if we go into the design of the prototype, there are many ways of making a blockchain database, and this is the one that we chose. We chose this one because of the different roles and responsibilities within the database. So we chose a private permissioned distributed ledger, and that means that a central kind of administrator of the system is responsible for permitting people access to use the blockchain database. So people from I don't know, people from Bitcoin mining cannot access the blockchain, the ledger that we've built for the biofuels use case. Only entities that have that currently hold a valid certificate under one of the biofuel voluntary schemes is permitted to use the system. And Bioledger became the permission issuer. So within the blockchain code that we wrote, we could identify that users want the capability to be able to record transactions where they collect used cooking oil. They can view that in their stock management system. They can split or aggregate consignments. They can sell those consignments to consumers. And we wanted to be able to provide a different level of capability to auditors who needed to be able to see all transactions in the supply chain. We wanted to also be able to limit the data that other users could see. And we also had to implement the consensus logic, and that has to be written into the blockchain code. The consensus logic had to be defined by the stakeholders, because the consensus logic is essentially what do we accept as a compliant transaction in our database. So we worked with RSB and the industry stakeholders to identify the typical rules for that a sustainability manager would perform on a new transaction before they would accept that into the database. And again, thankfully, because these systems are already developed, the companies have systems to report according to the voluntary schemes. So we could very clearly identify the data points that needed to be included in the consensus logic and what those due diligence checks were before we would accept one transaction into the blockchain. And both the consensus logic and the user roles are written into the blockchain code. Of course, the users can't interact with blockchain code, so we needed to develop user interfaces that represented the day-to-day business operations of each one of those users. So we needed to develop a mobile app for the driver who records the first piece of evidence. We needed to design a stock management tool that allowed a trader or a biofuel producer to be able to see all of their received compliant transactions and manipulate those to either aggregate them with the same type of consignment or split them apart into smaller consignments and then sell those consignments to a buyer. And they needed to do that by a web-based interface that they can all understand. And that interface with the blockchain database via this application layer. And the distributed ledger itself, so the blockchain code that hosts the consensus logic and the user role rules is stored in the distributed ledger, and any new transactions are again stored in the distributed ledger. And as we discussed, the distributed ledger needs to be hosted by trusted peers in the network, and by talking to stakeholders, we could identify the Bioledger as an independent company with no commercial interests, and RSB as a regulator, were those trusted peers that could host the distributed ledger networks. And in order to build this whole system within the constraints of the budget, and also to make best use of the available technologies, so that whatever prototype we build is in theory scalable to cover the entire market of the 20 million or so tons that are traded in the European market. So we worked with Oracle Autonomous Cloud-based services to host the blockchain distributed ledgers. And we also had a second parallel database that wasn't a blockchain database, that stored some of the non-critical commercial information, like the company names and addresses. And again, that was just to save cost. And I would say that because again of the budget constraints, we simplified all of the scope of the prototype. So the user interfaces could have been more complex. There's a world of Internet of Things devices that are mobile connected that would be extremely useful to create really strong and robust evidence, whether that's mobile phones or tablets that are used by drivers to record transactions and take photos, or flow meters or weighbridges. Those could be integrated into a blockchain database, but the only interface that we had in this prototype is the website. The consensus logic could have been more complex. We could have added more rules for due diligence on new users, and obviously with the ever-evolving renewable energy directive and the different reporting rules for biofuel sustainability into the different member states with additional reporting requirements, we could have made the consensus logic more complex, but we chose to keep it simple for the purpose of the prototype.
Patrick, sorry, Arianna,
yeah, I realized.
I just wanted to give you a 5 minutes warning so that we have some time also to answer some of the questions. Thank you.
Yeah. Okay. So I'll get really quickly through the prototype. So we built the web application and the blockchain database based in Oracle. This is the interface for a driver. So a used cooking oil driver would use this app to record the sustainability of the biofuel, the used cooking oil at the point of collection. Because their mobile has geolocation capabilities, we wrote the geolocation capabilities into the consensus logic. So the driver can only record a new transaction if the GPS coordinates of their handheld are within a 300-meter radius of the restaurant address that they say they're collecting from. And the consensus logic includes the mandatory reporting data that we set out here in the interface. This doesn't include all of the voluntary scheme reporting data. It just is an example. So when the driver records that information and proves that they really are where they say they are, then they try to record that transaction, and that will go through the consensus logic of the blockchain database. If it complies, it will get written into the ledger, and then using the second interface is the first collector depot account, and the administrator of the first collector depot account can see all of the consignments that they've received from their collectors. They can see the geolocation, the driver ID numbers, and the time and date of collection. They can then transfer those consignments to new new customers, and they can either transfer whole consignments or partial consignments. And the intention and the rules under the biofuels market are that you have to allocate an equal or lower quantity of sustainability data to a physical consignment. So that was the intention here. And then finally, for auditors, we wanted to be able to create that transparency. So there is an audit log of every transaction that happens, and the auditor can go into the account of each holder and see the previous transactions and track them all the way back to the point of first collection. So the prototype was tested amongst the stakeholders, and we validated the hypothesis that we could build a blockchain database that performed the business logic and the compliance logic of the users. They could collect, see, split, sell, and then audit all of the consignments according to the rules. It created extra transparency, and it created extra trust because those consensus rules were embedded in the system. I would say the limitations of this pilot project were that it was a small test amongst a small set of users. We could have made it far more complex, but we chose not to, and there were clear omissions from the user interfaces, and those were highlighted by the systems auditors from Peterson Control Union and STS. And I would say the benefits of this system are that, well, they're twofold. You have extra trust associated with each consignment now. So the users know that for a consignment to be in this blockchain database, it has to have been collected by a driver who performed that geolocation evidence at the beginning of the supply chain. The claims can't be used more than once because the peers in the network can see that that they're only used once. And actually, when a transaction happens, it's not like a traditional database where one account is edited to reduce the quantity that they have when they make a sale, and another copy of a database is credited, so they add stock to the buyer. In a blockchain database, the transaction is represented by an actual transfer and title of the consignment from the seller to the buyer. So everyone in the network can see who the new buyer is, and those transactions are all recorded in a chronological list of what has happened that consignment in its life cycle. And I think the best way to express that extra visibility and extra trust is to look at these interfaces that we generated. And these show the transactions from the point of origin through the trader to the final consumer. And in a very rich database, an auditor or a regulator can drill down into these into the statistics and look at the transactions that happen between the different entities and verify whether they're compliant or whether they're even plausible. They can also see the macro level flows of biofuels from different origins or of different claims. And yeah, I guess the outcomes of this project are that, yes, you can use a blockchain, you can configure blockchain technology to perform the jobs that we needed it to perform, and it does have beneficial characteristics. But the stakeholder engagement is critical to define the logic, define the rules, and to embed that trust. If everyone agrees that these are the rules that apply to the market, then everyone can take trust from that those rules. And again, governance is still the critical issue. So the European Commission is still talking to I think member states about how users should be able to access a database. But Bioledger now, based on the learnings from this project and based on the immediate demand for a solution, Bioledger has taken the learnings from this project and we've started from scratch again. We built a new mobile collectors app and a new database that will launch in 2 weeks. And we've opted for a very simple governance rule, and that is Bioledger will host the transaction information that is recorded by users, and users will assign an auditor access to their transactions. No one else can see those transactions. The auditor is responsible for compliance, and the voluntary schemes in the member states, if they have requests, can make those through the companies or through their auditor. And we look forward to launching that in the future. And if anyone's interested in this pilot project or our new database that launches, or maybe even other problems in different supply chains, I'm very happy to talk at a later date. Sorry, Arianna, I'll finish there.
No, don't worry. So thank you, Patrick. I will really briefly conclude with the RSB perspective. As I mentioned earlier, we are not just a certification, but a mission-driven organization. So that's why we get involved in projects like this one. Our aim is really to support innovations that really ultimately improve sustainability compliance and the credibility of certification, because the fraud case that came up a few years ago showed that, you know, sometimes sustainability certification can be improved as well. And also is important for us to ensure multi-stakeholder approach and consensus, and we wouldn't hesitate to recommend this type of technology, as we generally do in our standard, in our tools, to recommend technology and tools that the industry can use. And obviously, this is one of the options that is being suggested as a union database across the European Union. So it's very important for us to be involved in this type of discussions. So, and Patrick, if you go to the next slide, which is questions, thank you very much for all of you that shared questions. I hope you don't mind. We're going to be a little bit late, so it's almost 1 CET. We have some of the questions I already answered in the chat, but some I couldn't, so I'm gonna share them to Patrick. I'm gonna aggregate some of the questions around data privacy. So some of the attendees questions about so how does data privacy work within a blockchain database, and who is allowed to see which data?
Yeah, there's some really good questions here, Arianna, and apologies for not leaving more time.
So in the meanwhile, do you want to address maybe this question about data privacy, and which in a private blockchain, how would data be accessed by whom, and how does data privacy works?
Okay, yeah, so it all depends on the rules, and the rules are written into the blockchain code and regulated by the permission issuer, who in this case is Bioledger. So when a user would apply to perform in the database, they would have to justify their role in the supply chain, and that would then permit them to have the capabilities to do different functions in the database. And so if you take a couple of examples, if someone wanted to generate new consignments of used cooking oil in the database, they would need to prove to Bioledger that they were certified and capable to do that. So they would need to present a certificate as a voluntary scheme certified first collector of used cooking oil, and then we could add other due diligence requirements, but that would then allow them to have the role and the capability of having drivers and being able to perform those first collections. And even those first collections would need to still comply with the compliance logic then for creating new transactions, and that would be that that the geolocation of the driver is within a certain radius of the restaurant, and that the mandatory criteria are recorded. An auditor has a different set of responsibilities and therefore has a different set of capabilities within the system, and those again would be defined by Bioledger, the permission issuer, according to them justifying that role in the supply chain. And that would be they would have to demonstrate their accreditation to perform audits, and they would also have to show that that they were granted legal access to view the data for a specific user, and that user would also have to show that approval. So a company who hires an auditor would have to tell Bioledger this is the named individual from the named certification body who has access to our supply chain data within a certain scope or within a certain time frame. And then the named auditor would have security credentials to log in, but not only perform, well, read only rather than perform any transactions. And you can keep applying those rules according to different rules. Different companies can have kind of super administrator rules or read-only rules, or rules that are only permitted to perform like admin rather than transactions. And then, yeah, finally, the whole point of the thing is to provide transparency to the regulator. So it still has to be defined. All of this governance structure has to be defined by the users and the regulators. And I would say that was the biggest takeaway that we have, and probably the main barrier to how this happens, how this is used in the future, is that how do you reach that consensus about those rules? Who's responsible for developing this system if we're going to use one? Who will pay for it? Who will have access to the data? Who will be responsible for policing the transactions? What will the outcome of those investigations be? And how do we continuously improve the system to keep adapting to any new potential fraud events?
Thank you, Patrick. Also, just an aggregate of a few questions so in light of the existence of databases that are already very robust databases that transfer supply chain data that are not necessarily on blockchain, that are not on blockchain, but are on managed by one centralized service provider, but that are highly efficient, secure, etc. So what would you say are maybe, let's say, 2 or 3 advantages in summary of blockchain, which is basically kind of a summary of what we explained in the first slides?
Yeah, I think the industry and the commission have identified that if you digitize the supply chain, you instantly make it more trustworthy because it's more transparent, it's more efficient to audit. Digital claims can be policed more strictly than paper-based claims, obviously. So a move toward a database is absolutely a huge benefit to any sustainable supply chain. The advantages of using blockchain are those that we identified in the project, that we can increase the trust in the consignments because we've embedded that consensus logic that applies to all new transactions. We increase the trust because there is more than one steward of the data. So we might have a central administrator of a single database, but in a distributed ledger database, we can have multiple different trusted stewards, and those might be well, it's always better to have a few peers to review the evidence and to make sure that there are no there's no fraud and there's no implausible transactions in there. And I guess another outcome is that we developed a blockchain database that implements the business and compliance logic, and we did it within the budget of this pilot project. So the cost of developing a blockchain and implementing those extra security controls is not prohibitive. It might have been prohibitive 2 years ago. It might have been prohibitive a lot longer than that, but the pioneers of the industry have invested in the development of blockchain platforms as a service. They're off-the-shelf blockchain traceability databases offered by IBM and Oracle and Amazon, and those are cheap solutions to benefit from blockchain. And yeah, I guess another reason that we chose the Oracle autonomous blockchain service is because of that scalability. So most of the cost is in the development of the interfaces and finding people and writing the consensus logic into blockchain code. And the associated process of doing all of that stakeholder engagement and trying to find consensus. And the bigger your blockchain network and the more stakeholders you want to have involved in the database, the more complex that stakeholder consultation is. And I guess the more frequently you have to update your consensus logic. And yeah, I think that's complicated, and the development costs are by far the biggest cost toward running a blockchain database. The transactional costs are less than a tenth of a penny per transaction, so comparable to normal databases.
Thank you, Patrick. And so I think that's it for today. There are a few more questions that were left unanswered, and we are gonna share some of the information to address these questions next week via email. So your questions are not gonna be left unanswered. Also, for those of you who are RSB members and ICL members, we're going to be hosting a technical webinar next Friday at the same time. Here we're going to have blockchain developers, so the blockchain engineers that are going to address some of these technical issues. And also for those of you that are interested in RSB membership, you're most welcome to contact me anytime. And then lastly, in a few weeks' time, we're going to publish a report, a case study report, where we will highlight all of these topics, and also provide some more detail on the stakeholder survey and on how the blockchain database works.